In this video, we're going to talk about the Pythagorean theorem. This lesson is divided into 4 sections. We'll go over Pythagoras' theorem first, then a few examples that show how it's applied. We'll also briefly talk about the converse of the theorem, and we'll follow that with examples as well. I've added timestamps in the description if you want to skip around, so let's get started. A triangle that has a right angle, a 90-degree angle, is called a right triangle. The side opposite that right angle is called the hypotenuse. Notice that it's the longest side. Let's call it C, and the other sides, the shorter ones, A and B. Basically, the Pythagorean theorem describes how the sides of a right triangle are related. It says if you have a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the 2 shorter sides. In other words, C squared equals A squared plus B squared if the triangle is a right triangle. Example 1. Find the value of C using the Pythagorean theorem. Here we're given the lengths of the 2 shorter sides. Let's plug what we have into the formula. A is 3 and B is 4. 3 squared is 3 times 3, which is 9, and 4 squared is 4 times 4, which is 16. Add them up. 16 plus 9 is 25. Now we're left with C squared equals 25. To get rid of the power to find the value of just C, we have to take the square root of both sides. Why both sides? Because it's an equation, which means it's balanced. The 2 sides are equal. Applying change to one side will make them no longer equal. So any change you make on one side must be made on the other. So let's go back. The root of C squared is just C. The power and the square root cancel each other out. And 25 squared gives us 2 answers, plus 5 and minus 5. Because we're calculating the length of a side, it cannot be negative, so we only take the positive result, and so C is equal to 5. Example 2. Find the value of B using the Pythagorean theorem. We have C, the hypotenuse, 13, and we have A, which is 5. Let's plug what we have into the formula again. 13 and 5. 13 squared is 169, and 5 squared is 25. To calculate the value of B, we need to isolate it. Here we have a number, 25, added to it, and we have an exponent, 2. So we need to get rid of them both to find the value of just B. To get rid of the 25, we need to subtract it from both sides of the equation. Again, because you can't do something to one side of the equation and not the other. 25 minus 25 is 0, and that leaves us with B squared on one side of the equation. 169 minus 25 is 144. Just to make things easier, let's switch the places of B squared and 144. You don't have to, this makes no difference at all. Now take the square root of both sides. The power and root cancel out, we're left with B. And the root of 144 is plus or minus 12, and B is 12. Find the value of A using the theorem. We have the hypotenuse, which is 10, and B, which is 8. Let's plug what we have, 10 and 8. 10 squared is 100. 8 squared is 64. Subtract 64 from both sides. 64 minus 64 is 0, and we end up with A squared on this side. 100 minus 64 is 36. We'll switch the places of A squared and 36. Take the square root of both sides, and so A is equal to 6. Okay, so we talked about the theorem and what it means. Now let's talk about its converse. Basically, the converse of the Pythagorean theorem says, if you have a triangle, any triangle, and you square its sides, and the sum of the squares of the 2 shorter sides turns out to be equal to the square of the longest side, then this triangle is a right triangle. Let's compare. The Pythagorean theorem says if the triangle is a right triangle, then C squared is equal to A squared plus B squared, whereas the converse says if C squared is equal to A squared plus B squared, then this triangle is a right-angled triangle. Example 4. We're given the 3 sides of a triangle and we're asked if this is a right triangle. The converse says if we apply the Pythagorean theorem and we see that indeed the sides of the equation are equal, then the triangle is a right triangle. So let's start. The formula, C squared is equal to A squared plus B squared. We'll ask, is C squared really equal to A squared plus B squared here? Let's plug the numbers. C is 11, and A is 3, and B is 10. 11 squared is 121. 3 squared is 9, and 10 squared is 100. 100 plus 9 is 109. So we have 121 on one side and 109 on the other. The two sides are not equal. 121 does not equal 109, and so we can conclude that this triangle is not a right triangle because we added the squares of the short sides and the answer was not equal to the square of the longest side. We're asked to prove that this is a right triangle. How can we do that? Using the converse. If c squared is equal to a squared plus b squared, then it's a right triangle. So a is 2, b is 6, and c is 2 root 10. Let me just point out that it doesn't really matter which you decide to label a and which b. Here I said a is 2 and b is 6, but you can say a is 6 and b is 2. It doesn't really matter. It gives the same result. The only important one to label correctly is c, the hypotenuse. And you know that that's the longest side. That's the one opposite the right angle. So let's plug in the numbers. 2 root 10, 2, and 6. 2 root 10 squared, this can be written as 2 squared multiplied by root 10 squared. 2 squared is 4, root 10 squared is 10. 10 multiplied by 4 is 40. Now the other side. 2 squared is 4, 6 squared is 36. Now add them up. 4 plus 36 is 40. So because the two sides are equal here, we can say that this triangle is indeed a right triangle. And that's it. I hope this video helps. I'll see you again soon.